Okay, so in this video, we're going to take a look at the C++ implementation of the linked list. I'm going to kind of show you all the code in one file and compile it, and then we'll make a few tweaks to it. And this code will be available for you to look at and play around with on your own. Okay, so far we've defined a couple of objects, our classes, and an implementation of a few functions. And let me make this just a little bit bigger. So we have our list node class. I'm showing this here on the screen that has an item inside of it and a next pointer and a constructor to help us initialize it. And because I don't want to build up my own item object and make it unnecessarily complex, then I have a using directive up here that says that an item is really just a standard string. Note, this is equivalent in C to writing something like, type def, standard string, item. But in C++, you're encouraged to use the using statement instead of type def. It's stronger, it's more powerful, and more meaningful in the context of C++. And so you can think of this the same as type def, but a little more powerful. And in this case, item is just a standard string. So now anywhere we see item, we're really dealing with a string in the rest of this code. So that's our list node. And then inside list, as we've been assuming, we have a head pointer, we have a tail pointer to our list node objects. Our constructor initializes head and tail to null. And then we've implemented an append, an empty, and a remove function. And inside the class, I've simply declared these functions, or at least append and remove are declared, and then I've actually implemented them outside the class. And the reason I've done that is just that it's one, I want to show you that it's possible. And two, there are going to be situations later on when we start to separate our code out into header files and source code files. And once we start doing that, then we only want the declarations to be in the header file, and then the implementations will be in the source file. Okay, so this is the append function exactly like we had in the notes. And we also have the remove function here exactly like was described in the notes. Okay, so all of these worked. And then in main, I create a list, and to it I append milk, eggs, and bread. Okay, and then and this file is called list.cpp. And then what we can do, let me just do an ls and make sure that I have this file here. Yeah, so the file I'm working on is list.cpp. And then we can compile it. Now, some of my code here does rely on C++ 11, so I need to add this extra flag here called that tells the compiler to use C++, the version of C++ that was approved as of 2011. Okay, and that compiles my code, and then I run it, and it appeared to run. I don't know. I don't have any print statements in my code, so I'm not going to see anything happen, but presumably I appended milk, eggs, and bread into my list. So that's a little unsatisfying. I would like to be able to see what's happening in my list and verify that what I put into my list was really there. And so one thing I could do is I could add another function to my class that would let me loop over everything inside the class and print it out. And we'll do that in another video. But for now, I'm just going to do something simpler that allows me to prove that remove is working and append is working all at the same time. I'm going to write a little loop that removes things from the list one at a time and then prints them out. And since I always remove from the head, I'll be able to remove things in the same order that they were appended to the list and print them and show that, in fact, that's what was in my list. So to do that, I'm going to need an item that holds the thing that I removed. And then I'll have a while loop, and I'll say l.remove, and I'll pass in this item. And if it actually removes something, it'll stay in the loop. But as soon as I fail to remove something, it'll return false. Right? That's what happens up here in remove. If there's nothing in there, I'll return false. But if I do remove something, I return true. So this will just keep looping until there's nothing else to remove from the list. And then what I can do is, when I remove something from the list, I can just print it out. And let me let me make sure it's always on a line by itself. Also, let me make sure I have string and IOString. Okay, I do. Okay, so what I should see now after I compile and run this is that I will print milk, eggs, then bread. Maybe just to make it really clear, I'll add another integer here and also print that out. Okay, so I'll print a number followed by a period, followed by an item in the list, and then a new line. Okay, so let's compile that. And then we run it. And yep, I forgot to increment I. Let's start it at 1. Okay, let's do that again. Make this code look a little better. Okay, so we have milk, then eggs, then bread. In case you're doubting that this is really working, it's some kind of trick. Let's come in here and after eggs, let's add coffee. Coffee is pretty important. It's almost as important as bread. And we'll run this again, recompile it, run it again, and sure enough, I removed milk, eggs, coffee, and bread from my list. Okay, one other thing I wanted to point out, you may be looking at this l.append function here and see that I'm passing in a plain character string, and you may be saying, hey, how does that work? Because I thought that we were appending items. And if you look at my append function, it expects an item, and that's definitely not a string, and it's certainly not a literal character string. But remember, this using directive says that an item really is a string. And then string objects are allowed to be initialized using a literal string. And so the compiler figures out what we want to do here. It knows that really I'm passing in this literal string, but that can be converted to a standard string object. And then that standard string object can get passed to my append function and used to create the list node and so on. Okay, so this code will get checked in. You can play around with it. Hopefully it gives you a sense of the overall structure of the code we've written so far. And now we're going to make a few more changes to these, to the list object.